Hello, 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 and welcome back to another episode of Kerbal Space Programming. Kevin here, and we have Bob in orbit in his vehicle that is going to transfer to the moon. So I was trying to figure out kind of how we can make this a little bit less repetitive than some of our previous probe missions. Now, you'll notice we do also have a Kerbal engineering system attached here, so we can see that we have managed to get about 2350 meters per second worth of delta V, which is plenty to get to the moon and back. Probably not enough to land, but that's okay. The idea is we're going to get to the moon, we're going to get as much science as possible and bring it home in this capsule. Now, one of the things that we could try and work on is setting up a script. Yeah, you can see there's lots of connections, and our Omnisats are terrible. We shall soon replace you. But one of the things is that when we've transferred to the moon in the past, we've kind of gone through and waited until we have an appropriate target angle, and we haven't actually been computing that target angle. That's been kind of trial and error or Googling on my part, which is a little bit hacky. So one of the things that we could do is actually look at trying to compute what the correct phase angle is for us to transfer to various bodies, and we probably will do that in the future, but I wanted to talk about another strategy for KOS, and that is, what if we were to let the KOS system execute our maneuver nodes? So let me go ahead and I'll say target the moon. We'll set that as a target. And I'm just going to sort of guess that we probably want to do a maneuver somewhere around here. And just expand that up. And there we go. Perfect. And this is, we see, okay, so it's moon encounter, and I'm not seeing a periaps. So I think we probably got a little too aggressive there. There we go. Okay, so this would be a maneuver node, and this is something that you typically do if you were flying things manually. And this would give us a nice little periapsis. Let me go ahead and tweak this a bit here. But the idea is that what if we were, and actually, I think, let me see, that's weird. Whoa, okay. Now, we want to try and make this somewhat fuel efficient. Let me bring this up. We can see that this is going to require significant amount of delta V, probably more than would strictly be necessary. And what I want to try and do is bring this periaps down. Okay, so I actually have to go the other direction. 343. Okay, so now we collide with the moon. There we have a periapsis of 80 something. If I tweak this a little bit, 52. That's probably fine, 52. And then of course and that would boost us into a crazy orbit, but we'll take the time later to go ahead and actually circularize. But what we're going to do is we're actually going to write a script that will look at this maneuver node, warp to it, and then subsequently execute it for us, so that we're still not actually doing any flying, but Bob can actually do some mission planning. So we can prepare these maneuver nodes in advance, kind of evaluate how they will do, and then we'll let the craft actually be responsible for executing them. So let's jump over into some scripts. So here we are in our maneuver library, and we've written this in the past. We've got our burnout auto stage stuff. We've got our calculate time to complete a maneuver. We've got our home and transfer delta V requirement calculator and all that stuff. What we're going to add, and what I've added here, is a maneuver exec node. So we're going to execute a maneuver node. We're going to take one parameter, whether or not we want to automatically warp ahead to that node, or whether we're just going to wait the old-fashioned way. So what we're going to start by doing is saying local n is next node. Now this is something that we get from KOS. It's going to fetch the next maneuver node in our flight path. Now this will cause an error if there is no node. So we've got to be very careful when we execute this. Right now there's no way to determine whether or not a node exists. A maneuver node exists, so we only want to call this when we're sure we've actually got it set up. We're going to set V to that n, so the next node's burn vector. Now a vector, remember, is a direction and a magnitude. So in effect, we get three different values here. So we get like an x of 14, a y of 348, and a z of -5, or whatever it may be. We can think about this like if you were plotting a graph in 3D space. You have something that's going in the x direction, so maybe to the right by 14, it's going up by 348, and forward and backward by -5. So this basically just gives us the direction that we want to be burning and the amount, which is exactly what we want. Now we're going to calculate the time that we need to start our maneuver by taking the current time plus the time until we reach the node. So that's the node's ETA. We've done that like ETA to apoapsis and stuff. We get the same thing with nodes. And then we're going to subtract our maneuver time to complete a burn of the magnitude of the vector. So remember, the vector is a direction plus a magnitude. So we know that it's going to be, 800 delta V, for example. We're going to say, okay, let's figure out how much time it takes us to calculate or to burn for 800 meters per second. Now, we do get this sort of in the estimate on the screen, but we've actually computed it better because we can determine that even when the engine is shut off. We've got a function that we've already written that will give us the time that it takes to complete a maneuver. We're just going to divide that by 2 so that we burn time-wise split across the ETA to the node. Now, some people have pointed out in previous episodes that really we should be burning so that the delta V is split rather than the time, but this is a reasonable enough approximation. So this is going to give us the time when we need to start burning. We're going to lock the steering to that direction, to the burn vector. And we're going to say, okay, so if the auto warp that was passed in is true, then we'll just go ahead and say warp to the start time and minus 30 seconds. That way, if we need any additional time to get our steering set, we've got time to do that. So it's going to warp automatically using KSP's warp to stuff and get us to the place that we need to be. Next, we're going to wait until the time seconds is greater than or equal to the start times. We want to make sure that we don't start firing early, and we'll lock our throttle to the minimum, or actually I should have capitalized that, min, there we go, of the maneuver time, or 1. So this is interesting. What it's actually going to do, if we think about our maneuver time, let's say, for 500 meter per second burn is 12 seconds. Well, this is going to say, okay, the minimum of 5 and 1 is 1. So the lowest value is 1. But what this is going to do is it's going to say, okay, when our time to complete the maneuver is less than a second, let's throttle back. Right? So if it's only going to take us half a second to complete the burn, well, let's actually go ahead and throttle down to half. That way we make sure that we don't overshoot. And this actually comes straight out of the KOS docs. There's a little tutorial on executing maneuver nodes, and this was a very cool strategy. So I like this. So this just kind of eases us back when we're close to the end of our burn. Now we're going to wait until the dot product between these two vectors is less than 0. And this is a little bit confusing. We're definitely going to get more into vectors probably when we look at docking. But what we're doing is we're saying, okay, the current vector for the maneuver node and the vector that we stored, because remember we copied it over here into this V value, when the dot product between those is less than 0, which means that they're pointing in at least 180 degrees away from each other, well, then that means we're probably at the point where we have mostly, gotten close to overshooting it. So we'll go ahead and say that means that we're done. We'll lock the throttle to 0 and we will unlock the steering. And that is all that we need to execute a maneuver node with reasonable precision. There we go. That's the word. So let's look at the script that we've written to actually use this function so that Bob can do his maneuvering. Alrighty, so here we are in the Moonsea Autopilot, and this is fun. So first we're going to run that maneuver library, which I've already written a script to upload to the craft so that it gets the newest version, because we had the older version on there originally. We're going to notify that our maneuver autopilot is initiated, and we'll say, hit the RCS to execute the next maneuver, and hit the brakes when you want us to be done. So what this is going to do is it's going to set done to false, and then we're going to say on brakes, set done to true. So what this is doing, remember in the past we've used things like when. So we'll say, when alt radar is greater than 500, then, do something. Now this is similar. What this does is it effectively does the same thing. It's a little bit of a shorthand. What it tracks is this is a Boolean variable, meaning it can be true or it can be false. When we say on and we pass a variable name that is a Boolean variable, when it switches, when it goes from true to false or false to true, then it'll go ahead and execute this block. So if we turn on the brakes or we turn off the brakes, it's going to set done to true. That's what we want. So now we're going to set RCS state to RCS. RCS is either on or off, so we get true or false there. We're going to say until done. If RCS does not equal the RCS state, the one that we saved, well, then it means it must have changed. So you've either turned it on or turned it off. We'll go ahead and set the new RCS state to the current RCS. We'll say, okay, you clearly hit the RCS button, so we'll execute the maneuver, and we'll run maneuver exec node, and we'll say true. Go ahead and do your automatic time warping stuff, and then we'll notify done when that's done. Then we're just going to wait a tenth of a second every time in this loop, and this will run until someone has hit brakes and thus done is set to true. Then we'll notify, okay, good, the maneuver autopilot is terminated. So let's jump over and take a look and see how this plays out in action. Alrighty, so since we have this first maneuver planned, all we have to do is actually upload our script to our craft. Now, of course, this thing doesn't actually have connection right now because we have all of these antennae disabled. So we're going to let Bob go ahead and hop out and forcibly turn on this communitron. So force open. There we go. Alrighty, we'll go ahead and hop on in. And now I'll go ahead and upload our script. And as soon as this picks up, there we go. Maneuver autopilot initiated. RCS execute maneuver, brakes for done. So as long as we don't hit the brakes, we are going to be good. Let's go ahead and turn off the lights just because we want to make sure that, yeah, we're trickling electricity a little bit here. But let's go ahead and say, okay, so we've got a maneuver planned, and it's in 22 minutes. Now, of course, it doesn't give us an estimated burn, but we already have our estimated burn because we are good mathematicians. We can already compute that with other libraries. So we'll hit the RCS button, and there we go. It's now saying it's going to execute the maneuver, and so it'll automatically warp ahead, and it's going to give us a 30-second margin once it gets around. And unfortunately, because we are relatively low, we can't warp particularly fast. Now, this is using internally the KSPs is the same as if we were to click on an orbit and say, warp to here. So we have to give it a specified time. We say we want to warp until that amount of seconds. There we go. Okay, so it is slowing down, and now we can see that it is trying to turn itself into the correct direction. And there is a little bit, the cooked steering is a little bit finicky, so that's why we've kind of baked in this additional time. Let's see here. It's okay, so we know how much time it is to the maneuver node, but we actually backtracked from that the amount of time that we need to execute the burn. So let's keep an eye out here. Come on. You've got to be ready, aren't you? Come on. There we go. All right. So we are performing our burn, and we are right on that maneuver node, which is fantastic. Let's jump out to the map view, and we can watch this thing happen. And actually, I believe at this point, well, no, we need to leave the maneuver on until the maneuver is completed, because it is going to track the remaining delta V here, because it is using this as a basis for determining stuff, or at least it's using the direction of the maneuver, because as soon as the angle between the direction that we're firing and the angle of the maneuver node switch or become somewhat opposite to each other, it's going to go ahead and kill off. Because what happens is, as soon as you overshoot, then the target flips to the other side of the nav ball, at which point the direction that we're heading and the direction that we would need if we wanted our maneuver to be exactly what we had said are going to be a little bit different. But yes, we are picking ourselves up. Come on. And thankfully, once we get higher up, this starts to go a little bit faster. And once we get down to the last second, which we're probably getting close here, then this is going to start to linearly scale down just to try and avoid overshooting. That's a clever trick. This is largely based off of a tutorial on the KOS docs, so I recommend you head over there because this is pretty useful. And there we go. It is slowing itself down. We've got an encounter. And okay, it says it's done. Now, if we look, though, it did not do what we told it to do exactly. It got close, but we can see, well, it got really close, actually, 0.0 meters per second. But because we're doing this from so far away, the periapsis that it got is 75 meters versus what we intended, the 52. But you know what? For something where we're, firing that far away, that margin of error is entirely fine. And of course, now it's spinning all kinds of out of control because it introduced some wobble and then unlocked the steering and all that sort of stuff. So let us go ahead and warp up into a bit of a higher orbit. And of course, if we add additional maneuvers going forward, it'll go ahead and execute those. We just have to hit that. We have to toggle the RCS. Now, one of the reasons for doing this is that there's not an easy way at the moment to detect whether or not a maneuver node exists. It'd be really nice. I believe they are looking to add that in future versions of KOS. But the problem is that if you try and execute a maneuver node and there's no maneuver node written, then the program crashes and there's no sort of try-fail, there's no sort of error recovery mechanism built in. But of course, now that we are in higher space above Kerbal. Look at you. Beautiful, beautiful Kerbal. We can go ahead and get some more science because we want to maximize as much as we can. Let's go ahead and, I think we can, yes, we can deactivate this. We'll go ahead and get a crew report. It's very round. We'll grab some mystery goo. The goo feels right at home here, as well it should, and we'll observe the materials bay. The high radiation environments have caused a few of the samples to glow. Okay. And press match. It reads 0 as though we were in a vacuum. How very, very strange. And log the temperature. The temperature is hard because, yes, okay. Now, one of the things to note here, and it's going to be interesting to see, is that it's possible, I believe, because when we leave the craft, I think what happens is that causes the KOS system to reboot. So we probably will need to retransmit that update instruction. We could set it up as a startup script, but we're not going to worry too much about that. So we've recorded our observations about the situation. We got you all the way out here, and that's all you can come up with to say. Well, that is just wonderful. Let's go ahead and grab the data that we collected. Now, we did bring up 2 mystery goo, but we're honestly not going to use them because... well, we're not going to be returning them, and we can't store duplicate experiments in the same crew cabin, which is unfortunate, but we wanted to have both of these on here for balance because it makes things a little bit easier. We'll grab the data and restore, and grab this data. Yes, and restore, and get back up in there. And actually, let's make sure that we take the data from here first, and hop back in. Now, just to test this, I'm not sure if doing an EVA causes the thing to reboot, but let's turn on the brakes and just see if we get a message, because if we didn't, then it means that this thing rebooted while we were outside. Oh no, we didn't. Alright, but of course now that we have terminated it, well, we need to go ahead and upload the script again. So, actually, Bob, you're going to have to get back out, and we're going to ask you to turn this thing on. Set the target on that to our Keosat, which is not in range. Oh, no, that's a different thing. Okay, and force it open. So there we go. Keosat, yes, it says the current distance is 2.28 million meters and the antenna range is 50, and we are well in range. So let's go ahead and hop back in there. And I'll go ahead and just transmit our instructions again. At which point this thing, because now that it completed its update script, because the update script was blocking, and there we go. Okay. So what happens is, because the update script was blocking, it meant that it wasn't going to go ahead and reboot, but by default, this thing reboots every 10 seconds looking for new instructions if it doesn't have anything else better to do. So let's go ahead and deactivate this for now, and go ahead and continue on our merry way. So we'll go up, let's see, if we zoom out, and warp to, okay, so periapsis is still good. We'll warp to here. And as soon as we enter the moon sphere of influence, I think we can then do some additional tweaks. And we see we still got about 1,500 meters per second of delta V, which is fantastic. And come on. And we'll warp ahead a little more. It is always possible for KSP to overshoot with the warping sometimes, which can be problematic. But okay, there we go. We're now in the moon sphere of influence. Wonderful. And our periapsis is roughly where it was before. Sometimes that can change when you cross spheres of influences because of reasons that, I don't know. Okay, do some more crew reports. You look at the surface of the moon and try to find a good landing space. We're not landing. The inside of the craters might be the best option. That is good advice, because they tend to be relatively flat. We'll observe the materials bay. It is the same as it was when we were high over Kerbal. Well, that is unique and useful information. The goo seems to be less dense here. And managing the temperature is equally challenging up here. Now, some of this we already have, but bringing it back from and actually landing with this is going to be much more helpful. So we'll go ahead and record our observations about the situation, because, yes, that is clearly the most that you can possibly come up with. Take the data over here. I am happy to note, though, that this thing that KOS does not reboot when you leave, because if you switch out to the map view, for example, then it will reboot when you return to it, which is one of the reasons that we have the boot script set up the way that it is. So we'll, let's see, collect the data, restore, oh, there we go, collect the data, and restore. There we go. Okay. Now, I suppose one of the things that we can do is we can transmit the results of one of these mystery goos, but I think we may actually have all that we can get from transmitting anyway, so I'm not sure how useful that's going to be. Let's set up another maneuver. First, I want to go ahead and slow us down just by a little bit and bring our periaps in to say 32. That 32 sounds good to me. Actually, no, we're not steering. Old habits die hard. All right. And we'll go ahead and toggle the RCS. And there we go. It's going to warp us ahead, execute our maneuver node, be all super awesome, and hopefully hopefully the accuracy is not going to be as bad as it was before. Of course we have to wait the 30 seconds for this thing to get in here. Come on. Get in. Now, we will eventually, I think, what I'd love to do is go through and say, all right, we're just going to write a transfer script that says, we have a maneuver function that says, transfer me to the moon. And we can give it some margins for, I want to get there before such and such, and I can only use so much delta V and that sort of thing. And there we go. Very, very small maneuver there. And wrap it up. Come on. Done. Perfect. All right, close it up. And 32, so much more accurate out here because we are dealing with, the zoom, there we go. We're dealing with different levels of precision. We'll go ahead and set up another maneuver down here that will get us circularized. And we'll give ourselves a bit of a fair margin there. And that brings our periaps down just a little bit, but that's perfect. We'll go ahead and hit RCS one more time. Now, eventually we can actually assign this to action groups once we have upgraded our vehicle assembly building once more. And there we go, warping down all the way there. Isn't this the life? Now, I suppose you could consider this to be somewhat cheating because we are, we're not flying. We're not, executing any controls over the throttle or the steering or anything. We're simply setting up a flight plan and then allowing KOS to execute it. We are triggering stuff with the RCS, but that's more of a matter of us not being able to indicate this is a planning maneuver or this is maneuver that is ready to go and that sort of stuff. But okay, Burning's getting us circularized. Now, if this thing overshoots too much, then we do run the risk of our periapsis getting a little too low, which could be problematic, but ease back. And there we go. Look at that. See, the closer we get in, the more and more accurate these are. So this is supposed to be, let's see, I'm not sure which of these is the maneuver node and which one of these is, I guess the one that's wobbling has to be us. But yeah, we were targeting 224 and we ended up right around 224. So we'll go ahead and kill that. And now we can just get some science from around the moon. Wonderful. And of course we are spinning. Now we could transmit an instruction to lock our steering, but I'm just going to cheat a little bit. Let's get some low moon science. And, oh man, yes, I should probably look and see if they still have the crowdsourced science stuff, because these messages are getting relatively dull. The instrument reads 0. It's as if it were in a vacuum. And log the temperature. Wonderful. Let's do a crew report. Grab that. You look at the cold gray surface. It looks really beat up with craters. That is an important insight. And yes, and the mystery goo. Okay, so all of this is stuff that you can't get anymore. I would like to turn on the lights, but I'm a little scared to do that because I'm not quite sure how long we end up in the shadow of Kerb. And we'll go ahead and take the crew report data. Take all the rest of this data. Yes, Bob is just our good old workhorse, getting as much of this done as he possibly can. Because we want to, ideally what we want to be able to do is unlock some of the smaller parts so that we can get these really tiny little probes and vastly improve our, alright, yes, vastly improve our satellite network. So let's, have we done an EVA? We have not, or I think, yes, board. Okay, so now all that we have left, the remainder of these experiments, or at least the external experiments, really can only be used in a particular environment. So they are, while in orbit around the moon is where their science comes from. But the moon does have biomes, and the EVA reports will get different science depending on what biomes we are over. So if we warp ahead a little bit, or a lot of bit, let's see, I think, is that I think, yeah, we're just going to miss that biome, and we're not, and our orbit is not eccentric enough that it's going to vary as much as we might like. But Oh, now we're in high over the moon again. Okay. So I think we may need to actually... Whoa. Yes, actually, that is... Yes, we should have brought this down even lower. Let's add a maneuver again, and we'll bring it down. But also, while we're at it, since we've got a fair amount of fuel, let's go ahead and actually set ourselves up on an inclined orbit so that we can actually get more coverage over things. And that's going to be 178 meters delta V. So we can go ahead and hit R and warp around. Oh, I love this. Just complete and utter autopilot. Fantastic. But unfortunately, we will have to see the remainder of Bob's science collection and attempt at a valiant return in the next episode. So I will hope to see you then. Cheers.